All right, so we are going to continue topic 1, atoms in the periodic table, with lesson 2, the periodic table, found on pages 16 through 27 in your textbook. All right, as usual, we're going to start with our connect it. So the first thing we need to do is circle and label the different types of recyclable materials you see in figure 1. And here are several examples. There's a couple different forms of plastic. There's that black plastic bowl. There is what looks to be a plastic water bottle maybe. Then there's the metal cans, and of course paper. And all of these things are different kinds of recyclable materials. So next question, what things in your home do you sort or organize? Examples could be clothes, cans of food in cupboard, books, movies, pretty much anything. Medicine in a medicine cabinet. I know I sort my clothes like my shirts go. I have long sleeve shirts and all of those go together, and then all of my short sleeve shirts go together, and then all of my work clothes go together, and all of my comfortable home clothes go together, and I have different sections for all of those. Just like we have a drawer that we put things in. Different ways to organize things, and that's something that's really important with this topic. So, what problems might it cause if a company tried to recycle materials without sorting them first? Different materials are recycled in different ways. So what works for one material, such as paper, would not work for another material, such as glass. All right, so all of this brings us to how the periodic table is organized. And do you organize things according to their properties? Are all of your books together in your locker? Are your clothes organized according to whether they are winter clothes or summer clothes? Scientists also had a need to organize elements. By 1869, a total of 63 elements had been discovered. One of these scientists, Dmitri Mendeleev, discovered a set of patterns that applies to all elements. Mendeleev's work. So to find that pattern, Mendeleev noted each element's melting point, density, and color. He also included the element's atomic mass. An element's atomic mass is the average mass of all the isotopes of that element. Mendeleev noticed that a pattern of properties appeared when he arranged the elements in order of increasing atomic mass. Here we have figure 2, similar properties. So at room temperature, chlorine is a gas, bromine is a liquid, and iodine is a solid. However, all three elements share some physical properties. They also have very similar chemical properties. They are grouped in the same column on the periodic table. What common property do you observe in this picture? And all three of those elements produce colored vapors, regardless of the fact that one's a gas, one's a liquid, one's a solid. All right, using the periodic table. It includes the name of each element, its atomic number, and its atomic mass. It also includes its chemical symbol. This symbol is a 1 or 2 letter abbreviation for the element. The atomic numbers increase from left to right. Also notice that each color-coded region corresponds to a different class of elements. There are metals, nonmetals, and metalloids. All right, so the periodic table is a chart showing all of the elements arranged according to the repeating pattern of their properties. This is arranged according to each element's atomic mass. Could someone correctly predict the properties of the new elements? We now know that the number of protons in an atom's nucleus indicated by the atomic number is related to the chemical properties of an element. Therefore, modern periodic tables are arranged in order of increasing atomic number instead of by increasing atomic mass. So, we need to do a reading check. Explain, how is the modern periodic table different from Mendeleev's periodic table? And the modern table shows additional elements that had not been discovered during Mendeleev's time. Also, elements are now listed according to increasing atomic number instead of increasing atomic mass. Information in each cell. Figure 3. The periodic table contains one cell for each of the known elements. Each cell provides certain information about the element represented. Study the information shown for the element phosphorus. Then, using figure 4, fill in the information for the element zinc on the cell shown. and label each piece of the information. So first we have our atomic number. One piece of information is the atomic number of the element. It's shown at the top of each cell. For phosphorus, that number is 15. Every phosphorus atom has 15 protons in its nucleus. Next, we'll have the chemical symbol. It is in the center of each cell, and it is a permanent chemical symbol that contains either one or two letters. For phosphorus, that letter is a capital P. Chemical symbols with 3 letters are temporary and are used until permanent names are assigned to the elements. Atomic mass is at the bottom of each cell, and it is the average atomic mass of the element. For phosphorus, this value is 30.974 atomic mass units. The atomic mass is the average because most elements consist of a mixture of isotopes. So now for zinc. Our atomic number for zinc is 30. Our chemical symbol is capital Z lowercase n, and the atomic mass is 65.38. And of course, we use the periodic table to find all of this information. All right, and here we have a periodic table. So this is a modern periodic table. This is what we use now. This is what we will always use. So the periodic table, figure 4. The periodic table is one of a chemist's most valuable tools. Find the element identified by the atomic number 51 on the periodic table. Use the information to fill in the blanks below. So the name of the element. So we find 51. We can see that the name of the element is antimony, which we're going to write here. Then we're going to look at the chemical symbol, which I've circled here. It is capital S, lowercase b. And finally, the atomic mass, which is 121.75. All right, so now we're going to look at this modern periodic table and do our math toolbox applying the periodic table. So the order of elements on the periodic table enables scientists to predict properties about the elements. Answer these questions about the periodic table. What is the difference of the atomic masses of the heaviest and lightest elements in the table? And we can find the heaviest and the lightest. We subtract the lightest from the heaviest, and that gives us 293 atomic mass units. Examine the periodic table. Which 4 pairs of elements would be reversed in order if the elements were listed by increasing atomic mass instead of increasing atomic number? Cobalt and nickel, tellurium and iodine, lawrencium and rutherfordium, and flerovium and moscovium. When Mendeleev developed the periodic table, the element gallium had not yet been discovered. Without looking at the periodic table on this page, examine the elements surrounding gallium in the diagram below and predict the atomic number and atomic mass for this element. How does your prediction match the actual atomic number and atomic mass for gallium on the periodic table? So we know that the atomic number is going to be between 30 and 32, and that the atomic mass is going to be between 65 and 72. Therefore, we'll have an atomic number that is 31, and atomic mass should be around 69, or halfway between the values of zinc and germanium. Periods in the periodic table. The rows in the periodic table are known as periods. An element's properties can be predicted by its location in the periodic table. This predictably is one reason that the periodic table is so useful to chemists. Turn to page 132 and 133 and label the periodic table. So we have lanthanides and actinides. The elements in the top row are the lanthanides, and these elements are all found in nature and are sometimes called the rare earth metals. So this is the light pink in this image next to it. So then uranium and thorium are the only 2 actinides that are found in significant quantities in nature. Most other actinides are not found in nature, but are made artificially in laboratories. And that is going to be that dark pink, purple, magenta color. So lanthanides are the top of the bottom section, and actinides are the bottom. Transuranium elements. So none of these elements are stable. and each of them decays radioactively into other elements, with the exception of small traces of neptunium and plutonium. These elements are not found in nature. In general, the higher the atomic number, the more difficult it is to synthesize new elements. All right, so here we have figure 5, uses of lanthanum. So lanthanum, or capital La, like other lanthanides, is a soft, shiny metal. This lanthanide is a major component in batteries for hybrid cars and in permanent magnets. Label the lanthanum cell with the atomic number and atomic mass. So the atomic number of lanthanum is 51 and the mass is 138.91. All right, now we're going to do this question, and this one is important. If you'll remember earlier, we said that all elements have an abbreviation that is 1 or 2 letters, but then I also mentioned how some have 3 letters, and this is where that comes in. So, temporary element names. We said that those are temporary. This is us practicing how scientists do that. So, until scientists assign permanent names to newly discovered elements, the elements are assigned temporary names based on their atomic number. Each digit in the atomic number is assigned the root name for the digit. Then the suffix "ium" is added to the end of the name. For example, before element 116 got its permanent name, it was called un-hexium, from the roots for the digits 1, 1, and 6, followed by the suffix "ium." So we're going to use this table and imagine that 3 new elements are discovered, and they need temporary names. Use the information in the table to name the yet undiscovered elements with these atomic numbers. Then write the 3-letter chemical symbol for the element. So from the table, we know that 1 is un, so we would have un, and then 9 is in, so uninium. Uninium, which is abbreviated capital U, lowercase u, e. Then for 120, 1 is un, 2 is bi, and 0 is nil. So unbinilium, and it is labeled capital U, B, E. Then 121 would be unbiunium, and it would be labeled capital U, B, U. So then if we were to find 161, that would be unhexunium, and it would be labeled capital U, H, U. And it goes on using those same skills principles. So groups in the periodic table, and this is the part that is very, very important. So because the pattern of properties repeats in each period, these patterns can be used to classify elements that have similar characteristics into a specific group or family. So there are 18 columns in the table, and so there are 18 groups. Groups containing metals. If you examine the periodic table, you can see that metals make up most of the elements. At least one metal is found in every group, except group 18. So the metal group, we are going to, let's just read figure 6 first. The group shaded on the periodic table below contain the alkali metals, the alkaline earth metals, and the transition metals. Next to each element's name and image, fill in its chemical symbol. So lithium is capital L, lowercase I, magnesium, capital M, lowercase g, and gold is one of the oddly labeled ones, and it is capital A, lowercase u. All right, so groups containing metalloids and nonmetals. We have figure 7 here. The groups shaded on the periodic table below contain metals, metalloids, and nonmetals. Write the chemical symbol of the representative elements next to each photo. So we have boron. Its chemical symbol, I started with carbon here. So carbon is capital C, then boron is capital B, sulfur is capital S, and phosphorus is capital P. Apparently I was just being a little eclectic there. So now we're going to look back at the periodic table. There are nonmetals in group 1 and in group 14 through 18. Groups 13 through 16 also contain metalloids, which have some properties of metals and some properties of nonmetals. Next, we have the halogens, noble gases, and hydrogen. So again, the shaded area in Figure 8 contain the halogens, the noble gases, and hydrogen. Halogens are the most reactive nonmetals, which noble gases are the least reactive nonmetals. Hydrogen is a nonmetal that does not fall into a family because its chemical properties are very different from other elements. It is the simplest element containing only one proton and one electron. Now to do our labels. So we have hydrogen with a capital H, iodine with capital I, helium capital H, lowercase e. And while I did not read the descriptions for each of those elements, I think it would be important and relevant for each of you to please take your time and read each of those sections to kind of learn a little bit more about each group. And that brings us to our lesson 2 check. So in addition to properties of elements, list at least 2 other things or events that are periodic. Days on a calendar, months of the year, seasons, and phases of the moon are all things that are periodic. Assume that a particular atom of rhodium, capital R lowercase h, has a mass of 102. Why does this number not exactly match the atomic mass, 102.91, listed on the periodic table for this element? An atomic mass is an average of the mass of all isotopes in a sample. Many atoms have more neutrons than the atom mentioned, so the average mass is higher. And remember that an atom that has more neutrons is called an isotope. Now we're at 3. What element is found in group 6 and period 4? Based on its location, is this element more similar to tungsten or to iron? Explain. So the element is chromium. It is more similar to tungsten because they are in the same group. The noble gases in group 18 were some of the last natural elements to be discovered. Why do you think so? And elements are often discovered when they react with other elements or are found in compounds, but noble gases rarely react with other elements, and they are not commonly found in compounds. And that completes lesson 2.